Hello everyone. Let's see quickly some questions which are on Euler's theorem by using two variables. So it will be more clear for you. So here I have taken one question which is important. Here u is given as a function of x and y, and it has been asked us to prove x into del u by del x plus y into del u by del y is equal to 1 by 2 sine 2u. If you look here, this given function, we cannot say it's a homogeneous function. Why? Because we know if it is homogeneous, then we have to write it in this format, f of y by x, something like this. We have to write it. So if you take this highest power of x, we can take it out common. But if you can take it out common here, this is here, it is tan inverse function is here. So that is not under the consideration. So this is something which we don't want it. Tan inverse is something which we don't want it. So what we can do it, we can shift it into left hand side, and then it will become something like here. So this was our given function, u is equal to tan inverse of this one. So this whole function, if you consider together, it is not homogeneous. Okay. So but if you look at here, if you look at the function, this power, this bracket, then it will become a homogeneous function, because this numerator has order 2 and this is order 1. So this function, if you look at this bracket, that is the homogeneous function of order 1. So but overall function is not, along with tan inverse, it's not homogeneous. So what we can do is this tan 1 inverse, we can shift it on the left hand side. So this will become tan u. Tan u is equal to x square plus y square upon x by x plus y. And we can consider it as a z because we have to differentiate it further. So now this will become like a homogeneous function. So since it's a homogeneous function, now we can, by using Euler's theorem, what we can say that the highest power, we can take it out common, and we will try to write it in this format. Why? Because we have said that this is a homogeneous function of order 1. So that's a reason I can write it in this format. So what I did, the highest power, I took it out common from the denominator as well as from the numerator. So this came something like this, which is in the form of y by x. If I will cancel this out, this will be x raised to 1 f of y by x. So if you look at this equation, I can compare with standard equation of Euler's theorem, which is here z is equal to x raised to n f of y by x. So by comparing power of x with this one, we will get here n is equal to 1. Now by using Euler's theorem, what we can say, x into del z by del x plus y into del z by del y is equal to nz. Just now we found n's value here as a 1. So we can substitute that value here on the right hand side. So we will get equation 3 here, which is having n's power, n's value is equal to 1. So now if you look at the given question, that is given in the form of u. It doesn't have z. Z is something which we have considered it. So final answer should be in the terms of u, not in the z. So what we can do it, so whatever our consideration was there for z, z is equal to, we have considered tan u. So we have to differentiate this with respect to x and y, so that we can convert this in terms of u. The final answer should be in terms of u, not in terms of z. So now this equation we will differentiate with respect to x as well as y. So tan x, like how we do the derivative of tan x, it's a sec square x. Same thing will be here. Here also we will do, while doing the partial differentiation also, same way we will do it. This z we are differentiating with respect to x. So tan u's partial differentiation will be sec square u, and along with that we will multiply del u by del x. Similarly, we will differentiate this with respect to y. So del z by del y is equal to sec square u into del u by del y, because we are differentiating with respect to y. So now we got these two values here. So simply what we can do it here, we can substitute those values here in equation 3. So this is our equation 3, x into del z by del x plus y into del z by del y. So in that, instead of this, I have put the values which I found it here. So now the equation will become something like this, x into this whole value of del z by del x. I just kept it over here. So now what we can do it, here if you see in the bracket, this is common. I can take it outside from both the terms. So left over will be x into del u by del x plus y into del u by del y, which is equal to tan u. So simply I can shift this term on the right hand side, so it will get divided. So which I did it here. So we know that tan u is nothing but sin u upon cos u, and sec square u is inverse of cos. So that's why I can write it here. So one cos will get cancelled over here. So simply I will get sin u into cos u. And if you look at our right hand side, which we have to prove, it's very similar to that one. Simply we have to use one formula. If you remember, you have studied it in class 2. Sin 2 theta is equal to 2 sin theta cos theta. This is very often you have used this formula over that we have to use here. Here instead of only theta, this is in terms of u it came, but actually the same formula we will be applying over here. So instead of this sin u cos u, what we can write it is sin 2 theta, or here it is u. So sin u by 2, or 1/2 sin 2u. This is the formula I used it here just by rearranging, and this is nothing but the RHS which they ask us to prove it. So simply we have done, if you remember, if you go to the previous slides, since tan inverse was something which we were creating the whole equation as a non-homogeneous equation, we shifted to the left hand side. We considered that as a function of z, and then we differentiated with respect to x and y, and substituted that whole answer in terms of u, so that we get the final answer in terms of u. This is how we simplified or solved this question. Hope you understood this one. Thank you.